The beam moves, slowly at first, a long iron arc describing its geometry against the brickwork, then settling into a rhythm that has not materially changed since the year Disraeli entered Parliament for the second time. This is Uffculme, Devon, the Coldharbour Mill working wool museum. And this engine, this particular engine, has a history more complicated and more improbable than anything the building around it has ever seen. It was built in 1867 by a firm called Kitto and Brotherhood at their works under the railway arches on Compton Street, Islington, London. It was built for a brewery. It spent 67 years turning grain into beer in Whitechapel. It cracked a bed plate in 1934 and was retired. It was rescued from the scrap man by the Science Museum. It was dismantled. It was stored. It was moved. And then, in 1989, a group of volunteers in Devon began putting it back together. In 1993, it ran again. It is probably the only beam engine built by Kitto and Brotherhood that still exists anywhere. It runs on steam days. The beam moves. The Watt governor spins. The oil flows through the Beddoes lubricator to the piston. The flywheel, 15 feet across, turns. This is not a decorative machine. It is not preserved in the sense of being frozen. It is run, regularly, by people who understand what they are looking at. That distinction matters more than it might appear. Coldharbour Mill has been producing wool since 1799. It was built by Thomas Fox, a Quaker, which in the industrial context of the early 19th century meant someone who felt a philosophical obligation not to treat his workforce as raw material. The Fox family ran it for generations. At its peak, the Fox brothers' concern employed approximately 5,000 people across 9 mills in Devon, Somerset, and Oxfordshire. The mill in Uffculme ran commercially until 1981, 182 years of continuous production. When it stopped, English Heritage called it, in a formal historic buildings report, so probably one of the best preserved textile mill complexes in the country. The beam engine in the engine house was not part of that original story. It arrived from elsewhere, from Whitechapel, and was installed not because it belonged here, but because here was one of the few places left that could house it, maintain it, and actually run it on steam. That arrangement turned out to be exactly right for both parties. The mill had an engine house, but no engine. The engine had nowhere to go. The Science Museum had one condition attached to its donation. The engine, when installed, must be run. It is. Peter Brotherhood was 28 years old when this engine was built. His father, Roland Brotherhood, was a civil engineer who had employed 1,000 men digging the sunning cutting for Brunel's Great Western Railway. It was Roland's workforce that Isambard Kingdom Brunel called upon in December 1844 to cut out the masonry holding the SS Great Britain in her Bristol dock after her launch ran her aground. The Brotherhood family did not merely observe the Victorian engineering revolution. They were in it, up to their elbows. Peter served his apprenticeship in his father's railway works in Chippenham, then at the Great Western Railway Works, and then with Maudslay's Sons and Field in Lambeth, at the time the foremost precision engineering company in the country. The men who worked at Maudslay understood what a machine surface should look like and what it should do. That education is visible in every part of the engine at Uffculme. In 1867, Peter entered a partnership with a man named Kitto at works beneath the railway arches on Compton Street in Islington, and their principal product was brewing machinery. The Albion Brewery in Whitechapel commissioned this engine, a rotative beam engine to drive the brew house. The partnership between Kitto and Brotherhood lasted 4 years. In 1871, it dissolved. Brotherhood continued alone, moved to Peterborough, and went on to invent the 3-cylinder radial engine that powered the Royal Navy's Whitehead torpedoes. The firm he founded survived under various names until 2015, when it was acquired by Hayward Tyler Group. The engine he made in 1867 outlasted every subsequent iteration of the company that built it. The design of this engine is not modern, that is the point. The beam, the sway beam, pivots at the centre on trunnion bearings. The upright cylinder below it pushes the near end down. The connecting rod at the far end pulls the crank. The vertical orientation was not a stylistic choice. Early designers believed, with some practical justification, that a horizontal cylinder would have its piston worn through the bottom by its own weight, given the lubrication materials available in 1867. A vertical cylinder kept wear even. The engine does not use variable cut-off admission, which later became standard in mill engines. It uses a throttle valve, a simpler, earlier approach. Steam enters and leaves the cylinder through the same passages in the same valve, which means the valve is alternately heated and cooled with each stroke. This is thermodynamically inefficient. The engineers at Compton Street almost certainly knew this. They built it anyway, because for a brewery application, driving a line shaft at modest speed, so reliability and simplicity of maintenance mattered more than thermodynamic elegance. Speed is governed by a Watt-type centrifugal governor. Two heavy balls on articulated arms that rise with increasing speed and throttle back the steam supply. It is not sophisticated. It is accurate enough. It has been doing this without modification since the engine was built. The piston rod is kept perfectly vertical by Watt's parallel motion linkage, an arrangement of 3 bars that constrains a point moving in an arc to travel in a straight line. Watt patented this in 1784 and was, by most accounts, more proud of it than of the separate condenser. The bearings are lubricated by sight glasses and siphon pots. This is worth pausing on. A siphon pot is a small oil reservoir with a wick that feeds oil by capillary action to a bearing surface. The sight glass allows the operator to confirm, without stopping the engine, that oil is flowing. The system requires no pump, no pressure line, no electrical signal. It requires a wick, oil, and someone who looks at it regularly. The piston receives a heavier grade of oil through a Beddoes displacement lubricator, a device in which steam pressure forces oil from a reservoir into the steam supply, where it mixes and carries lubrication to the cylinder walls and piston rings. A hydrostatic sight glass confirms that oil is present in the lubricator reservoir. These are not the lubrication systems of a machine that was designed to be serviced by specialists. They are the lubrication systems of a machine that was designed to be serviced by whoever was available, with whatever tools they had, in whatever time they could spare. The visibility is intentional, and the simplicity is a design decision. An engineer who needed complex equipment to monitor this machine would be an engineer who might miss something. The Beddoes lubricator does not permit you to miss something. You can see the oil. You can see that it is moving. You can see that it is sufficient. The Victorians who built this engine understood something that was later unlearned, that a machine you can read by looking at it will be maintained better than one that requires instruments to tell you what it is doing. In 1934, the bedplate cracked. The bedplate is the structural foundation of the engine, the massive cast-iron base through which all forces are transmitted to the floor. A cracked bedplate on a beam engine of this scale is not a maintenance item. It is a terminal diagnosis. The engine in the Albion Brewery in Whitechapel had been running for 67 years. The brewery decided it had run long enough. The engine was offered to Trowbridge Town Council in June 1978 by Watney Mann, the brewing conglomerate that had absorbed the Albion Brewery's operations. It had been stored, and the Science Museum had become involved, stipulating that if the engine were ever re-erected, it must be made to run. This was not a request, it was a condition of salvage. The engine was dismantled by Historic Steam Limited, a body connected with the Kew Bridge Engine Trust. It was moved to Bradford-on-Avon for storage. In 1989, it was transferred to Trowbridge. A few years later, the Coldharbour Mill Trust took it. What followed was 4 years of work by a group of volunteers with the knowledge, the patience, and the stubbornness to put back together something that had last been running when the Hoover Dam was under construction. The Science Museum's condition was the right one. Engines do not survive by being kept still. They survive by being run. The restoration was carried out by volunteers. This is not a minor detail. The bulk of the engineering work was done by a group that included John Babb, Andy Horner, Jerry Tottle, Alan Hunt, Jeff Hayden, Mike Perkins, Rob Brotherston, and others. People with the practical knowledge to read a Victorian engine, diagnose its condition, and correct what 3 decades of storage had done to it. The piston rod required machining, and it was sent to Peter Brotherhood Limited in Peterborough, the direct successor firm to the company that had built this engine 120 years earlier. The firm machined the rod at no charge, noting that the guarantee had expired somewhat some time ago, 120 years to be more precise. The columns and entablature went up first, giving the engine house the classical proportions that the Compton Street pattern makers had intended. Then the trunnion bearings. Then the sway beam. Alignment was achieved by straight edge, plumb bob, and spirit level, the same instruments that had been used to set it in Whitechapel. The crankshaft presented a particular problem. It was too long to fit the engine house at Uffculme. Permission was sought from the Science Museum to shorten it. Permission was granted. The engine ran for the first time at Coldharbour Mill in 1993. The volunteers did not require a ceremony. The machine running was ceremony enough. The engine at Uffculme is maintained by the Coldharbour Mill steam team, volunteers with a range of backgrounds in mechanical engineering, maintenance and industrial heritage, who come in before a steam day, raise the boiler, run the engine, and then bring it back down again in the correct order. The knowledge required to do this is not written down in any single document. It exists in the people. It was transmitted from the original restoration team to those who followed, and it continues to be transmitted now. There is a version of this process that is very familiar to engineers who have worked on old machinery. You learn it from someone who learned it from someone else, and at no point does a manual capture the particular sound this valve makes when it is correctly seated, or the exact feel of the governor linkage when it is running in trim. The Science Museum's stipulation, "Run it," was not simply about keeping the mechanism exercised. It was about keeping the knowledge alive. A machine that is run has people around it who know it. A machine that is merely displayed has visitors. The volunteers who received the King's Award for voluntary service in recent years did not win it for what they have preserved. They won it for what they continue to do. Preservation in the passive sense, the cleaned up, roped off, do not touch sense, is not what this is. This engine is working. The distinction is not semantic. There is a reason this engine is described as probably the only surviving example of its maker's work. Kitto and Brotherhood dissolved in 1871. The firm became Peter Brotherhood. The works moved to Peterborough. The engineering focus shifted to high-speed engines, to torpedo propulsion, to turbines and compressors. The beam engine style, slow, vertical, simple, maintainable, heavy, was superseded. Not because it failed, because faster, lighter, and cheaper were available. The machines that replaced beam engines in the late Victorian and Edwardian period were more efficient. And they were also more complex, and complexity has a cost that does not appear in the initial specification. It appears in the maintenance record. The Pollitt and Wigsell cross-compound engine installed at Coldharbour Mill in 1910, still running today, cost £1,810 new, which equates to approximately £218,000 in 2020 terms. It drove all 5 floors of the mill via a rope race until commercial production ended in 1981. The Kitto and Brotherhood engine did not drive the mill. It was not built to do so. But the principles embedded in its design, maintainability, accessibility, transparency of function, are not brewery-specific. They are principles that were once understood as prerequisites of engineering. The engine at Uffculme is not a relic. It is a demonstration of a philosophy, one that, it should be noted, still works. The beam moves, same motion, same rhythm, same 15-foot flywheel, same watt governor rising and falling as the load varies, same Beddoes lubricator feeding the same cylinder through the same passages that have been alternately heated and cooled, 600 times an hour on every steam day since 1993. This engine was built in 1867 by two men working under the railway arches in Islington. One of them went on to power the Royal Navy's torpedoes. The engine they built together went to a brewery, spent 67 years making beer. The cracked bed plate was saved by the Science Museum, was moved twice, was stored for decades, was reassembled by volunteers using straight edges and plumb bobs, and was made to run. It will require maintenance before the next steam day. The usual things: lubrication checks, valve packing inspection, water gauge glasses cleaned, boiler flues examined. The same maintenance it has always required. The knowledge for all of it exists in the people who do it. It is not a mystery why this engine still exists, and it exists because it was designed to be understood, repaired, and run by whoever was available. It exists because the Science Museum insisted it must run. It exists because a group of volunteers in Devon spent 4 years putting it back together. It exists because the maintenance chain has not been broken. The machine is still running. What was built correctly does not require our indulgence to survive. It requires only our attention.